thank you so much for joining us today. Before we officially kick this off, I do want to point out to all the audience members, if you have questions during today's discussion, we welcome them, and please post them in the Q&A section at the bottom of your screen. And with time permitting, we will hopefully get to all of the questions. If we don't, I apologize, and you can always reach out to me after the webinar, and I can connect you directly. So I'd like to now turn this over to Stephen Saltzstein, Forest Family Office's CEO. Thank you.
Thank you, Callie, and thank you everyone for joining. We greatly appreciate you taking time out of your day to be with us. You know, if you just look at the headlines today, it's Pakistan shoots down Indian drone after nuclear warning. Then Ukraine pinning war hopes on expanding drone program. Then Trump misled about the dangers of drones over New Jersey. And just yesterday, my son flew his drone 1,000 feet in the sky. So to say that this technology is ubiquitous and the leading edge of asymmetric warfare is an understatement. And it is my great pleasure to have John Shepard with Cord, part of KBR, and of course, Chris Donaghy, CEO of Applied Energy. So gentlemen, thank you both for being with us today. We really look forward to having a robust discussion about drones and defense and the future of asymmetric warfare. Chris, if you don't mind, just starting with you, can you just give us the basics? I mean, who is Applied Energy? What makes pulsed laser technology different from conventional directed energy systems? Just like lay the groundwork.
Yeah, thanks, Stephen. Thanks, everybody, for joining us. So Applied Energetics is an early-stage defense technology company focused on developing and fielding directed energy systems based on ultra-short pulse lasers. And there are several advantages of ultra-short pulse lasers that you'll probably hear reinforced over the course of this conversation. But the first is that these systems are generally a low average power system, meaning that the lasers that we're building, you could plug them into a wall. They would use about the same amount of energy as your garage door opener. You can plug them right into the prime power of whatever the platform is that you desire to deploy it on. And the benefit of that is, as you look at laser-based directed energy systems, they tend to scale with average power. So if you compare our 100-watt average power system to, say, a 300,000 watt, a 300 kilowatt system, you would see a massively dramatic change in the size, weight, and power footprint associated with that system. So because we are a low average power system, we have a significant advantage in lower size, weight, and power footprint required for the system. The second point is, even though we are a low average power system, we are an extremely high peak power system. So you take the low average power, you slice it up, you compress each one of those slices to fractions of a fraction of a second, and you can drive your peak power of these systems on the order of billions of watts of energy. And when you get billions of watts of power into the optic of a small drone camera, for instance, it's a near instantaneous kill. You are ablating the surface of the sensor, you're drilling through the top layer of the sensor into the circuitry in the back, and it's a near instantaneous kill. So we're trading that low average power for high peak power in order to get the more significant instantaneous effects on the sensor itself. And when you compare that again to a continuous wave laser system, we're drilling through in fractions of a second to destroy electronics versus a continuous wave laser, which is used to melt through a critical component and cause the system to fail. And what you'll hear us talk about over the next several minutes or so is, what are the benefits of being able to do both of those on one platform, and why can that really make a difference? And then the last thing is, our architecture is based on fiber optic architecture components that gives us wavelength agility, meaning we can build lasers using different types of fiber optic techniques that can achieve wavelengths across a broad range of operational parameters, from visible sensors all the way through long wave infrared sensors. And if we can do that, that gives you a match of about 100% of the types of cameras that you would find on the modern battlefield. And where we can match the laser wavelength to the sensor wavelength, there is no countermeasure for that camera to avoid the effects of the ultra-short pulse laser. And it's nearly impossible to stop the camera defeat when we match the wavelength to wavelength of the camera to the wavelength of the sensor. So those are kind of the three primary advantages that we see of what we're doing.
So when you cut up the beam, and what'd you say? You cut it up into billions of slices? Is that right?
We cut it up so we take the low average power and we dice it up into several thousand pieces per second, and then we compress each one of those pieces to fractions of a fraction, tiniest fractions of a second that you can imagine, and that increases the peak power to somewhere on the order of billions of watts when we hit our design objective.
And so, for instance, do you know how many photons are in each slice, or is that's too difficult to measure?
I'm sure there's probably a calculation, but we know the performance parameters of those pulses when they are generated. And generally we are not at liberty to talk about the specifics of what the energy levels and the actual pulse durations are.
But it's just so incredible that, I mean, basically you can use, at least initially, the power of like a light bulb to create something that can be, such an effective force.
Correct. And I'll tell you, I've been here 2.5 years, and the math still boggles my mind sometimes. You're just not used to dealing with numbers that are so big and at the same time on the opposite end of the spectrum so small.
Right. Hey, and I just want to tell the audience that there are certain things that are just too sensitive we can't talk about. So please bear with us if we get onto topics that just become too much information. We're just going to move past that. But John, once again, thank you so much for being with us. Can you tell us a little bit about Chord and the Firefly high energy laser weapon system, and how Chord fits in with KBR, which is a much larger public company?
Yeah, my pleasure. It's great to join this audience. So Chord is a wholly owned subsidiary of KBR, purchased a couple years, about 4 or 5 years ago. And we have a couple different directed energy, high energy laser programs. Probably the biggest one we have is what we call DEM short. It stands for directed energy and maneuver short range air defense. That's with the Army, with an organization called RCTO, the Rapid Capabilities and Critical Technologies Office, and that's the office for the Army that does really innovative technology and tries to get that out as quickly as possible. So directed energy is one of those things that they do, and the other, for example, another one would be hypersonics. But we've had that contract for several years now, and what we've done on that is integrate 50 kilowatt lasers onto the Stryker combat platform. So a 8x8, medium armored vehicle, and we've built 4 of those up and delivered them, and have actually deployed that operationally. And we're in the midst of doing a couple more on that. On the other side of things, which you mentioned, Firefly, that's an internally funded and developed laser weapon system that right now we have a 10 kilowatt and a 20 kilowatt laser.
Yeah, that's great. So Chris, now that you're showing everyone Firefly, can you talk about, or at least like give us a better idea of how your system integrates with Firefly?
Yeah, so I'm sitting here in the Applied Energetics Battle Lab, and there's 2 primary things that we intend to do out of this Battle Lab. The first and foremost is to demonstrate effectiveness. The feedback that I've heard over and over from both prospective customers as well as prospective partners is, okay, we hear you telling us what you're telling us about these ultra short pulse lasers. When can we come see it? So we expect by the middle of the year to have representations across most of the wavelengths that we're developing operational here in the battle lab with an ability to do static demonstration testing. However, we also expect to integrate one of those ultra short pulse lasers into the cord system itself. So systems integration is the second thing that we intend to do out of this facility. And the history of the company so far, we have been very much focused on developing the laser sources. We now need to learn how to work with the folks who build systems like Firefly. The Firefly gets us all of the other stuff that we need to make this an operational system. We have a laser source, but we need the systems management and support infrastructure. We need the command and control capability, the operator workstation, the fire control station, and then we need that white gimbal that you see on top there that does the target detection, acquisition, tracking, and ultimately pointing of the laser downrange to deliver the effect on the target. So we're very excited to work with Cord because this is now creating an operational version of a laser that will be integrated into a full system.
Chris, take us to the macro in the sense that, you were just at the European Counter UAS Forum, and that definitely framed the urgent and fast evolving drone threat, that is, really come to light here, especially when you take the Ukraine conflict, etc. Can you just talk about what you saw and what you learned there? John. I said Chris.
Yep, John. Yeah, John.
I figured that's what you meant.
Yeah, sorry, John.
Yeah, and just for perspective, I'm a retired Army officer, so I've spent 22 years in the Army, so I kind of had an understanding of the operational impact that drones are having, and I understood how they've been coming on. I think the first time I really heard about drones operationally was probably other than the ones that the U.S. Army was using that were really kind of larger, more expensive, more exquisite systems. I think about 2014 when the Russians invaded Crimea in Ukraine was the first time I really heard about an operational use, and it was very impactful then, and it kind of started everybody taking notice. What I learned a couple weeks ago, it was kind of actually shocking that the amount.
You said it was shocking? I just want to make sure. I'm having a little trouble.
Oh, sorry.
Do you mind getting a little closer or turning up your volume just a little bit? Because I apologize. Yeah. Thank you.
Yeah, thank you. Now, I would shocking is probably the right term. The number of systems and the different types of employment that we kind of learned from the Ukrainians and when they briefed was not quite what I expected. I think we probably call drones now ubiquitous across the battlefield, and they are absolutely a paradigm shift, similar to what our country experienced in Iraq and Afghanistan in the early 2000s with the kind of the advent of the improvised explosive device. What I think the Ukrainians are seeing, and the Russians for that matter, is they just constant back and forth on progressions of drone technologies, counter to the counter. So drones now make up probably the most significant portion of their offensive capabilities and their defensive requirements. So that typically was, direct weapon systems or, artillery and rockets and missiles. But I think in this case, it seems that drones have taken that over. There are many flavors of them. We in the U.S. classify them by, group or class 1, 2, 3, really by size and capability. And they're seeing all those, and they're seeing them on a daily basis. And the Army and both the Ukrainian Army and the Russian armies are incredibly adaptive. So I think it was probably I think what they said was about 85% of the damage or destruction done to both personnel and equipment are done by drones now, which is completely a change in warfare.
I saw this piece in the Wall Street Journal. It was a 12-minute video, and they followed one of the reporters embedded with a drone platoon from the Ukraine. And two things became incredibly obvious to me, which was, one was, at one point, at one point, the Ukrainians launched a drone and the Russians essentially took it over. And then the Russians took it over, sent it back on the Ukrainians, but the Ukrainians could watch the drone that the Russians had taken over to bomb themselves.
Yeah,
And the other was that, you know, these drones are swarms, right? Like, you know, there's air drone, and this is just me being a layman, but there were air drones supporting ground drones. And if an air drone got caught out, another air drone would automatically, using AI, go and take its place.
Yeah, they essentially said that if you detect one drone, there are more around. And detection is one of the difficulties for them. But they, you know, they're using different ways to try to defeat these now. They've used GPS jamming, they've used RF jamming. They have tried. They even use spotlights at night to try to blind the sensors on some of these things. And some of the counters to, for example, to the jamming is they used fiber optically controlled drones. So they're, you know, it's got a direct link back to the operator with the fiber, just to get around some of these things. They use drones against other drones, and to counter that, they started putting cameras on the back end of the drone so they could see 360 degrees around it and know if they were being targeted by another drone. They've even mounted shotguns on drones, believe it or not. So you have flying shotguns, because as a default, in a fallback to, you know, not being able to defeat them with other means, they actually still use shotguns on the ground and have roving teams of folks, even on four-wheelers or trucks, that have mounted guns and then their own personal arms that they're trying to use to defeat the drones. It's an incredible problem.
I mean, it really just feels like an Arnold Schwarzenegger movie.
It certainly looks like that nowadays.
Yeah. So Chris, I mean, look, so there's radar, there's RF jamming, there's lasers, there's kinetic guns, right? There's all of wide range of counter drone approaches. Where do you believe you guys fit in? Pulse laser systems. I mean, what is the biggest advantage that you're offering?
Well, the first thing I will say is that there is no silver bullet to solve this problem right now. So regardless of the capabilities, this is going to be a layered defense approach where you're going to use multiple effectors to try to solve the problem. So where we fit in, I would say one of the unique things that that is an outcome of an ultrashort pulse laser based system is a pretty significant shift in the engagement economics. Engagement economics are, how much do we have to spend to counter a threat versus how much does the enemy have to spend on their system to deliver that threat. The kind of macro data point here, when the Iranians attacked the Israelis a few years ago with missiles as well as drones, it was estimated that the Iranians spent about $300 million on an attack that used dozens and dozens of drones and missiles. The equivalent response from the combination of the Israelis and the Americans cost $1.3 billion. So it doesn't take you long to realize that those engagement economics do not work. And so directed energy has always been about bringing down the cost per shot to the lowest level possible. And because ultra-short pulse lasers, and because of the fiber optic type architectures that we're using, and the low average power systems, we can generally build those systems more economically. So we will have a very attractive cost per shot profile when those systems get deployed. But Firefly is also at a cost point that is, I think, significantly lower than competitive systems as well. So the combination of these two things, I think, present an engagement economics statement that is an engagement economics vision that is pretty unique and differentiated.
I mean, one thing that people need to understand is you're using this blinding effect, right? The applied energy technology enables this blinding effect. But, you know, that isn't bullets, right? So theoretically, I mean, because you use such low power, I mean, it's very, very inexpensive And it's not like you have to reload the gun, etc. Right? So I guess my question is, can you talk about how the blinding effect works, and why taking out a drone's vision system is more effective than actually just destroying it?
So that's a little bit of a complicated question. So I'll start off with, we talked a little bit about this, but again, when you're talking about peak powers that are ultimately measured in the billions of watts, from a tactical range, a kilometer or beyond, what you have to think about and realize as well is that the drone camera itself is a magnifier. It takes energy, it takes light energy from outside, it puts it through a lensing system, and that lensing system focuses that energy on a sensor at the back. Well, with highly intense laser light, we take advantage of that lensing system as well. So it takes that amount of energy that we get into the aperture of the camera, and then it magnifies it even further. And ultimately, that's what leads to a drilling effect on the back of the sensor. So, for example, we have microscope data that shows the effect of the laser on some of these sensors at the microscopic level. And generally what you see is it gouges a hole, a vertical hole or a horizontal hole through the sensor. And when it gets to the circuitry on the backside, it's an instantaneous kill. Let's see, the second part of the question was,
well, why is it more effective than destroying it physically?
Okay, right. So there's generally, and John is the former Army officer here, so I may turn it over to him as well, but you can think about this in two different mechanisms. There is a mission kill. What was the purpose of that drone? And generally with small drones, it's either a surveillance mission, launch the drone, see what's on the other side of the hill. Obviously, if you kill the camera and the primary mission of that drone is surveillance, the mission is over. And generally what the pilot would do is hit the return to home button, and the surveillance drone would just fly back to where it took off. The second purpose for small drones is delivering a small explosive to a target that is generally moving. Small drones with small explosives are not going to be used very often to strike fixed targets. So that drone is also going to be heavily reliant on the camera system to complete its mission. So again, if you can take out the camera at a tactical range, the likelihood of the pilot being able to hit that drone or hit its target in motion is 0%. So these are mission kills, not system kills. A CW laser is more of a system kill. But again, John and I had a conversation about this last week when he was at Applied Energetics. Mission kill versus system kill is something that the Army does every day. And John, I'll let you just kind of amplify on that. So this concept of not doing complete destruction of the platform is something that happens on the battlefield every day.
Yeah, and if you can destroy the target, that's great. But if that's not achievable, then you want to prevent it from being able to perform its mission. So on other systems, you may have mission kills, you may have mobility kills, you have catastrophic kills. I think it's normal within different types of weapon systems. I've worked on rockets and missiles that's the type of kill criteria that they use. I think the beauty of this particular, technology is the vast majority of drones have sensors, and most of them are using cameras of some sort to either scout for ISR, intelligence, surveillance, and reconnaissance, or to deliver some kind of effect, like Chris mentions, that maybe they've got a grenade or a bomb of some sort, explosive attached to it. If you take out the ability for the operator to see, it's done. And the other really interesting part of that is the operator probably will have no idea what happened that caused them to lose it until they get the system back, and if they're able to look and see that what damage was done. I think that's an incredibly powerful thing, and to be able to do it at, at ranges that keep those UAS away from the areas that you're trying to protect. I think it's very powerful. I think it's going to be a very sought after system once this thing is proven out.
By the way, is Cord, was it homegrown at KBR, or were you guys in acquisition?
We were an acquisition. So, Core Technology was originally a small woman-owned business. We got bought by a group. The company was called Centauri, but it's part of Arlington Capital, which was then purchased by KBR around 2020, 2021. A little off on my dates there.
Gotcha. Okay, great. Hey, Chris, do me a favor. So you're in the Battle Lab in Tucson. What kind of real world demonstrations are being done there? And I would imagine kind of hands-on testing is so important for someone like John.
So again, the primary mission of what we're doing here in the Battle Lab right now is effects testing. When a customer says, all right, I heard you say that you can use an ultra-short pulse laser to take out a drone sensor, I need to come see it. And so they want to be able to come in and have one of our lasers up and running, have some targets downrange, and show them that we can deliver a sub-second kill to a tactically relevant platform anytime we want to do it. Again, the second purpose is going to be integrating into real-world type systems. So, we build laser sources right now, and we are learning through the Cord platform how to put the entire system together. The laser, plus all of the command and control system, plus the targeting, surveillance and pointing system. That's as real world as it gets. And the goal is to have one of our lasers in this platform right here, wrong finger, this platform right here, and ready for outdoor testing by late summer. Cord has an outdoor test range. We'll integrate our laser into this thing, and once we're comfortable that it's operational, we'll take it out and we'll do testing in a real world type of environment.
That Firefly system is pretty big. So how big is your system?
Our laser will be probably no more than the size of 2 shoeboxes. So that is one of the advantages here, is they can put a 20 kilowatt continuous wave laser in this system, and there is still enough room for us to integrate our laser into that system as well and get the dual effect system that we think will be interesting to lots of different customers.
Will this work for high altitude threats or even space-based systems?
So I've had a couple of conversations with various folks on the government side, and as you think about the Golden Dome system, right? So the Golden Dome, we're going to spend untold billions of dollars trying to build a comprehensive missile defense or air defense shield. A critical layer of that system is going to be the ability to deny the adversary an ability to perform surveillance. So counter electro-optic sensors, the ability to kill cameras at all altitudes, that is going to be one of the important layers of this system. And again, this is where things get sensitive really fast, but it needs to be an all altitude system. And if you're going to be at certain altitudes, size, weight, and power are really, really going to be a big deal. And that's why we think ultra short pulse lasers have a role to play regardless of the altitude of the system, because we bring that size, weight, and power advantage to the table.
John, how do you think the collaboration between AE and Cord makes each organization stronger, both from a market access and tech standpoint?
I think we've already seen that. you know, in most of the engagements we have with various customers, and I think I mentioned that Firefly specifically was internally developed, which means we have, you know, the ability to do direct commercial sales, which we are seeking to leverage internationally. So, you know, there's, whether we're talking to a domestic U.S. government potential customer or international, you know, we bring along this idea that, hey, we're partnered with somebody that is Applied Energetics, that is integrating this new capability into our system. So we like to advertise that we have a modular system. Well, they're demonstrating the modularity by integrating a completely different laser into that system. And we also recognize, as Chris has talked about, the powerful piece of having our laser weapon system with this pulse laser system on the same platform, having two capabilities resident on the same platform, I think is something that's not, I don't think anybody else is doing. There are folks who are using kinetic effectors, i.e., think guns, large caliber, guns, or smaller rockets, and in some cases even missiles, on the same platform as a laser, which I think has some inherent problems with the laser. But the other piece of that is, with those kinetic effectors, that's not suitable in all situations, because you fire something like a gun or a rocket, it's going somewhere. It hopefully will hit its intended target, and if it doesn't, it's going to hit something. And today's battlefield is not linear anymore. It's a nonlinear battlefield. You got friendlies all over, so you have to pay attention to that. And the other thing I think we haven't really talked about, we're very focused on the tactical military application of this, but drones and their potential use, nefarious use, is not exclusive to military. This, critical infrastructure, government buildings, stadiums, anything is a potential target. So I think that it's probably a matter of time unfortunately, before somebody uses it in that way. But I think what we've seen is that civil protection is also a component of this. The border, for example, they're looking at putting these on the border, different systems down there because of drones carrying drugs across the border. So the application is far beyond military, and the type of technology both that Cord has and that Applied Energetics has, I think, has a play in all that.
One takeaway you get from really understanding the theater of war between Ukraine and Russia is so much of what the Ukrainians are doing is homegrown. Right. I mean, it's just like, I'm not going to go as far to say it's built in a lab. I mean, it's kind of like built in someone's military garage. And so that really highlights what you're talking about in regards to domestic threats.
Well, it certainly does. And the fact that you can take a 16-year-old, maybe even younger, take a 15-year-old kid, hand them a drone controller, and they will figure out how to fly it.
Oh yeah.
And then you talked about the engagement economics that Chris mentioned. These are very cheap. You just can't afford. You can't afford to counter every drone with an exquisite, expensive weapon system. Your cost per engagement has to at some point equal the cost of that drone, or you're always going to lose out.
This is the very definition of asymmetric warfare. What are the biggest hurdles to this system, or this combined system, becoming a program of record?
Yeah, I think it's
Chris, you want to? I don't know who that question is for.
So again,
Chris?
so the Cord system is set up as a commercial product. Our system, we are in essence developing it as a commercial product. We're using a combination of a little bit of government money and investor money to accelerate this thing and do it faster than we would have been able to do if we had gone down a traditional DoD procurement pipeline. At the end of the day, the ability to attach to an already existing program of record is really what you want to do. So John's system, for example, the DEM SHORAD system, I mean, that is already attached to a big Army program. It's a lot easier if you're a technology insertion to an existing program versus trying to have your own program created. You know, especially for small companies, the likelihood of that happening is, number one, very small, and number two, the time frames to do that can take a long time. So again, for us, learning how to do systems integration and integrate with platforms is really going to be critical for us to drive long-term success. That doesn't mean that, I mean, we have begun the design work to do a tripod-based system that is capable of being a standalone. Here's the laser, here's the gimbal, here's the controller operator workstation. You know, go to town with it. We have to have that kind of capability, mainly because it would demonstrate the smallest form factor of a complete solution that we could put together.
Two more
The
questions
main point
before
here is that, I was going to say, the main point is that we have been building this thing. We've been developing this capability. We've been doing the research and development on this system for 5 years now. And, you know, I saw there was one of the questions in the Q&A is, how well known is ultra-short pulse lasers as a possible counter-drone system? It's not very well known because substantially all of the government funding has gone toward continuous wave lasers so far. So we are at a stage right now where we are transitioning from pure research and development into hardware that can be demonstrated. And, you know, again, when combining it with an existing commercial platform, ultimately, we think that's what is going to drive significant interest across the board.
How big is the total addressable market?
So directed energy is projected to be $32 billion by 2032. Counter drone is expected to be $12 billion by 2032. Lasers, whether it's ultra short pulse lasers or continuous wave lasers, are going to be a part of that. We sort of have a vision that if we can build that tripod mounted system small enough and inexpensive enough, it becomes the front line of defense. You can deploy these lasers at the edge of the area you're trying to protect. And it actually helps the continuous wave laser guys, because if we are out there blinding all of the drones in this swarm, it buys time for the continuous wave lasers to then lock on and do the system kill of those systems. So I think lasers are going to be a significant part of the market. The one thing I will say, our vision statement here at Applied Energetics is directed energy anywhere. And directed energy anywhere is a pretty bold statement, because right now, every laser program you read about in whatever publication, every single one of those is an experiment. There is no such thing as a program of record that is buying directed energy based or laser based directed energy systems on an annual procurement basis. They're all prototypes and experiments. And, you know, frankly, the only way you're going to see a vision statement like directed energy anywhere come to fruition is to solve the size, weight, and power problem and be able to deliver results against relevant threats in sub-second timeframes. And if we can do that, you know, I think we will see the very wide adoption of our lasers.
How should family offices, you know, listening today, think about the value creation, of the potential value creation of a JV like this? I mean, you know, why should they be paying attention to Applied Energetics and Chord or KBR right now?
So Chord already has two very visible directed energy programs. One with one of the highest profile buyers of these systems that there is. That's the Army's RICTO in Huntsville. And now they also have a commercial platform that is capable of being sold into international markets. So they have customer relationships and resources to reach other parts of the market, as well as the systems integration experience that we will ultimately need. They bring that to the table. We bring a highly differentiated and unique effector into that mix that we think will ultimately give joint prospective customers more value than a standalone single effector system would deliver.
John, you may not know this, and it's not your job to know this, but I'm curious, how many analysts are covering KBR? And if you don't know, it's totally fine.
I can't answer that,
Yeah,
honestly.
right. Fair enough. Chris, how many analysts are covering Applied Energetics?
0.
You're at 0.
Yeah.
Okay. All right. That seems like an opportunity. Okay.
Yeah, it's the challenge we have to overcome there is just the OTC, the OTCQB listing. So when we make the move to a national market, I think we can change that pretty quickly, but there's just a lot of hesitation to pick up coverage of an OTC.
I mean, do you have plans over the next 12, 24 months to uplist?
Yeah, absolutely.
Okay. All right. Tally, 16 minutes. There's a bunch of audience questions.
Okay, and I will.
Thanks,
I'm not going to rush it, so I apologize if I don't get to all of them. But again, you can always reach out to me. Everyone has my email address. So there's a lot of talk about Iron Beam and Golden Dome. How would USPL play into one of these programs or solution sets? And are you seeing any inquiries about your capabilities on such a platform?
Yeah, so we kind of answered this during the main course of the webinar, and that is I have had conversations with parties who are working on Golden Dome solutions, and we continue to emphasize that you are going to need a counter EO layer. You're going to need something that can kill the things that are staring at you. We think ultra-short pulse-based laser architectures are the best solution for that, again, because of the size, weight, and power benefits that we bring to the table.
And John, how do you see this second laser source will differentiate you in the marketplace?
Yeah, I think it gives us something no one else has. It's 2 different kill mechanisms that are both, directed energy based on the same platform. That has utility in different situations that I think that could be broadly used, both tactically and domestically. I think this, we didn't talk about it, but if you think, if you go back and do a Google search about UAS incursions at Langley Air Force Base in the last couple of years, that's probably an application for this system that has 2 different effectors on it. So.
Thank you. With this collaboration, your technology will move from TRL4 to TRL5 or TRL6 in a short period of time. Are there new buckets of funding that you could go after with the new TRL designation?
Yeah, so TRL stands for Technology Readiness Level, which is a measure that the DoD uses to evaluate new technologies as they move from a concept into we're ready to start buying these things in volume. And the middle of that stack is kind of the TRL 5-ish perspective, which means you have a breadboard type prototype system that has been demonstrated in a relevant environment. And certainly as we integrate into the Chord platform, that starts to get you the ability to prove higher levels of technology readiness levels, because you move from a breadboard to a box, and you move from an indoor testing environment to an outdoor testing environment. So they absolutely serve as an accelerator in terms of our technology readiness level.
And let's talk a little bit about the technology. Since you're disabling the sensor rather than bringing down the drone, how is battle damage assessment done?
So there's a couple of different techniques that that we will likely deploy to answer that question. The first is when you hit a sensor with an ablative type function where it's drilling a hole in the back of the sensor, that can create a plasma flash that could theoretically be picked up by a camera system that is looking down the same barrel as the laser. So you can look for that flash and you can know, all right, if I see that flash, I formed a plasma, and therefore I can determine that that sensor is likely dead. The next thing you can look for, and again, this is where AI likely plays a role, is there an immediately obvious change in the drone's behavior? Meaning if the pilot is flying toward a certain target and all of a sudden he goes blind, there's going to be a reaction there. And the drone is going to do something that you could recognize as what just happened. Something just happened and I can't see anything now. So it'll be a combination of effects that we'll be on the lookout for.
And can you talk about the tracking and beam steering issues? Hitting a moving camera lens with a femtosecond pulse of light seems impossible. How are you solving this?
Okay, so there's again, there's a multiple pronged approach here, but I have seen AI models trained where, here is a system, and then you isolate a single part of that system, and you do that across multiple different platforms like that. And what you're doing is you're training the model to look for the camera system. That is one way to do it. Another way to do it is if we achieve high enough power levels on the pulses, we don't have to have pinpoint accuracy of putting, a 2 millimeter wave inside a 2 millimeter beam inside a 2 millimeter hole on a drone that's flying at 80 miles an hour. What we need to do is make sure that we have a spot size that is large enough to encompass the front of a drone camera system, and we need to make sure that there's enough energy in any one given square centimeter of that spot size that is sufficient to do enough damage on the target. And I'm sure you can't quite get into the details, but that cord system is capable of holding a very tight beam at a pretty long distance on a fixed spot. But John, I'd kind of defer to you on that, but some of these problems have been solved already by systems integrators.
Thank you. And for John, what exactly will you have to see in terms of the demonstrations to be convinced that applied energetics laser works? Is there a certain peak power, a certain distance of delivering effects?
I think the initial thing is the proof of concept. Can we integrate this into the Firefly? Can we take it to the field, and can we reliably demonstrate that it does exactly what we think it does? And some of the tracking issues, we'll have to work through. It is a difficult thing to put a beam on a very specific spot on a moving drone, but I think we can overcome that. So I think the proof of principle is really the first thing. Can we, and targeting this summer to take that out. Then it's about expanding that proof of principle to understand capabilities. How far out can we push? Can we push the capability? How many kilometers do we get? And then to me, it's about, your TRL level, as Chris talked about, goes way up. And we at that point, we have a demonstration system. Now we can start getting in front of potential customers and not talking about it, start showing them. And I think that's really what starts generating interest.
Thank you. And in terms, again, for John, of rough timing, when do you expect to begin purchasing applied energetics? Is it this year, 2026, or do you have any expectations?
I'm not sure I understand that question. Purchasing the system?
The lasers for
Oh,
Firefly.
I think it goes back to question I just answered is we're going to do the demonstration, then we start combining both companies worth of business development and marketing teams getting together, bringing customers in, doing those demonstrations. I think with the pipeline that we have, that we introduce, and some of the customers, some of the non-traditional customers that we've been talking to, I think that starts accelerating once you start the demonstrations. And I think probably 26, 27 timeframe, it would be about the time we would be doing that.
As this is a pulsed system, what's the time delay between pulses and shots?
Again, we can't get into specific performance parameters, but it's generally thousands of shots per second. Not millions, but thousands.
Any interest overseas for USPL or AERG collaboration?
I think there will be. I don't think this is something we've engaged directly on with the international folks that we've been talking to. It's one of those things when we're early in that business development process. I think it's probably a little premature to have that discussion. To me, like I laid out, once we have a demonstrator, then it's about grabbing those same potential customers, bring them all together, and showing the system.
Well, that's all the time that we have for the questions. For the audience, if you have additional questions and want to dive in deeper, please reach out to me. Happy to facilitate a connection here. And also everyone at Applied Energetics will have your information as well, and we'll be reaching out. So I do want to turn it back over to you, Chris, for any final words before we close out today.
Nothing too significant to say other than, thanks for participating. I know that we didn't get to all of the questions. If you have follow-up questions, please feel free to reach out and we'll try to get you answers where we can. Thanks again for your time. And John, thank you for your time as well. We sincerely appreciate you committing the time and resources to support this for us.
Thank you so much. Thank you. Have a great day.